Welcome to day 7, derivatives in tables. So we're going to do the chain rule, the product rule, and the quotient rule, but instead of applying them to functions that have formulas with x's that we have to move around, we're going to do it with numbers inside of tables. The rules are all the same, except we're not finding a general formula. We're finding the specific derivative for this very specific x value given to you. So our first one is going to be chain rule, a function inside of a function. So the idea is that we did from the outside in, and we're doing the same thing, except we're now going to apply it to these type of functions, depending which order is first, and to this table of values for the given x's and f, g, f prime, g prime values. I have to scroll back and forth between the tables, but basically it's going to work out. Here we go. H prime, well H, so it's really going to be f of something, and that means I have to do f prime of that something. And then the u stood for g of 3. So that derivative, I should draw an arrow here, that derivative is g prime of 3. And when I multiply my box, I get it's f prime of u times g prime of 3. Well, the u is just g of 3. So if I do this in pieces, I'll move it up just a little bit. Well, g of 3, I go to 3, I find g, and that answer is 2. And I do f prime of 2 times g prime of 3. I go to 2, I go to f prime, and that answer is 4, times I go to 3, I go to g prime of 3, and that is 3. My final result is 12. So h prime of 3 is equal to 12. Excuse me. I'm going to have to do the same thing, except it's kind of a reversed order. So first, I have g of something, and the derivative is g prime of something, and the u represents f of 3, and the derivative of that is f prime of 3. So when I multiply this out, I get g prime of u, which is just f of 3, times f prime of 3, and I plug this all in. Well, f of 3, I go to 3, I go to f, that answer is 1. So I have g prime of 1 times f prime of 3. I go to 1, g prime of 1 is 2. Get rid of that. G prime of 1 is 2, and then I go to 3, and f prime of 3 is 0. I get 0 as a result. So m prime of 3 is equal to 0. Okay? It's doing the same thing, but we're not working with formulas, we're working with numbers inside of a table. Okay, number 3 and number 4 are exactly the same as 1 and 2, except I've changed the input for x. So instead of being f prime of g of 3 times g prime of 3, I put in a 2, and I'm going to change everything. And I have to go back to the table, so you got to pay attention. So I'm going to move up to the table, go to 2, g at 2 is 1. So that's a 1. So I go to do f prime of 1 times g prime of 2. And I go to 1, and f prime of 1 is 0 times, it doesn't even matter because g prime of 2 is 4. And 0 times 4 is 0. So h prime of 2 is also equal to 0. Come over here. I go to f of 2. F of 2 is 1. So now I have to do g prime of 1 times f prime of 2. I go to 1, and g prime of 1 is 2 times f prime of 2 is 4. So I get m prime of 2 is equal to 8. So the outside function for this example is the square root of u, or u to the 1/2. I take its derivative, and the inside stuff is g of x, but specifically I'm using 2. So I did my derivatives, and I'm going to multiply. I'm going to get 1/2 of u, and u is just g of 2 to the negative 1/2 times g prime of 2. I have to go back to my table and figure out what is g of 2. Well, g of 2, here's 2. G of 2 is 1, and g prime of 2 is 4. So when I do all this, this is 1, so I have 1/2, 1 to the negative 1/2 times 4, which is a half times 1 to any power is 1 times 4. So I get p prime of 2 is equal to 2. Same thing for this next one. The outside function is something squared, so the derivative is 2 times something, and u is equal to f of x, or excuse me, not f of x. Actually, f of 0 is the x I'm using, so I have to do f prime of 0. And I multiply the box. I get 2 times, not u, but f of 0 times f prime of 0. So I have to go back to the table to find all this stuff. F of 0 is 2. F prime of 0 is 3. So I go back. I get 2 times 2 times 3, which is 12. So b prime of 0 is equal to 12. So the chain rule is a little bit more difficult when we're working with tables. It takes more work. You have to pay attention a lot more. So let's do product and quotient rule with tables. I think you'll like this better, especially when we just established what the crisscross is. So here's my same table. We know our derivatives. Here's my product. Here's my derivative for product rule. So when I do h of 0, well, h is just f times g. So it's f of 0, f prime of 0, g of 0, g prime of 0. I set up my crisscross. I'm going to do that way first. G of 0 times f prime of 0 plus f of 0 times g prime of 0. I just go find these numbers in the table. G of 0 is 4 times f prime of 0 is 3 plus f of 0 is 2 plus g prime of 0 is 1. And I get a final result of 12 plus 2, which is 14. So h prime of 0 is equal to 14. We can do the exact same thing for 1 that I just did right now, except I'm going to put a 1 in for everything. So I get g of 1 times f prime of 1 plus times f of 1 times g prime of 1. And I find all these numbers in the table. So g of 1 is 1 times f prime of 1 is 0, plus f of 1 is 3, times g prime of 1 is 2, and I get 0 plus 6, so h prime of 1 is equal to 6. So number 3 and 4, I did exactly the same thing I did for 1 and 2, except I changed the input for x to 2 and 3. Instead I used 0 and 1 for the previous problems. It's not really any different. So how about when we have a function times a function where it's not just the functions that are from the table. So right now I have the square root of x is one function, or x to the 1/2, and that derivative is 1/2 x to the negative 1/2, and the other function is g of x, or better yet, well, I'm going to do it a little bit different. Once I set that up, I could use x equals 4, and I get 4 to the half is 1/2 times 4 to the negative 1/2, and I do this all right. I get this is 2, and this is really a half times a half, so I get a fourth. And now I'm going to do g of 4, and it becomes g prime of 4. And when I do my crisscross, I do it this way first. 1/4 g of 4 plus 2 times g prime of 4. If I go to the table, g of 4 is 1 plus 2 times g prime of 4 is 0, and my final result is that p prime of 4 is equal to 1/4. Move this over just a little bit. So I have 3x squared, its derivative is 6x, but I could use x equals 2, and I plug 2 in here, and I get 12, and ironically I get its derivative is also 12, and now I have f of 2, and its derivative is f prime of 2. I'll do my crisscross this way first. 12 times f of 2 plus 12 times f prime of 2. I get 12 times f of 2 according to this table is 1 plus 12 times f prime of 2, which is 4. So I get 12 plus 48. I get b prime of 2 is equal to 60. So now we're going to work with quotient rule, where we have a numerator and denominator function, and my rule is basically the same as before. Low d high minus high d low over low squared. So when I work with this, well, I'm given h and m is defined as given. So h is going to be f of 3 is the high, f prime of 3, g of 3 is the low, g prime of 3. I do my crisscross this way. G of 3 times f prime of 3 minus f of 3 times g prime of 3 over g of 3 squared. And if I look in the table, move this up a little bit, I don't need those guys anymore. If I look in the table, g of 3 is 2 times f prime of 3, 0 minus f of 3, 1 times g prime of 3 is 3, all over 2 squared, and I get negative 3 over 4, or h prime of 3 equals negative 3/4. Now it's going to flip up for this next one. G is the high function, so I have g prime of 3. F is a low function, so I have f prime of 3. I do my crisscross. Got to do this way first. F of 3 times g prime of 3 minus g of 3 times f prime of 3 over f of 3 squared. And I use my table. Squeeze the table a little bit. F of 3 is 1 times g prime of 3 is 3 minus g of 3 is 2 times f prime of 3 is 0, and f of 3 is 1 squared, and I get my final result as 3 over 1, or m prime of 3 is equal to 3. So these next two problems, I did exactly the same thing as 1 and 2, but I replaced all the x's with the number 2. Both of them turned out to be, the derivatives turned out to be 0. It's not too bad. So now we're going to do it when we don't have both being numbers from the table. So my upper is, my high is 2x, which is 2. Now I can plug in x equals 1. So I get 2 when I plug in x, and the derivative is just 2. Now I'm going to do g of 1, g prime of 1. I'll do my crisscross. 2 g of 1 minus 2 times g prime of 1 over g of 1 squared. And if I go to the table, it's going to be 2 times g of 1 is 1 minus 2 times g prime of 1 is 2 over 1 squared. And this is into 2 minus 4 over 1, or, did I make a mistake here? G prime of 1 is 2. Yep, I'm using x equals 1. I get negative 2 over 1, or p prime of 1 is equal to negative 2. Interesting, on my old notes I made a mistake. Okay, now I'm going to bring this over here. I'm going to use, so 3x squared, that derivative is 6x, except I'm going to use x equals 0. Plug in 0, I get 0's derivative is 0. Yeah, kind of ruins everything. F of 0, f prime of 0, and I do my crisscross. 0 times f of 0 minus 0 times f prime of 0 over f of 0 squared. Well, it all becomes arbitrary, but it is 0 times 2 minus 0 times 3 over 2 squared is 0 over 4, or b prime of 0 is equal to 0. Not the best example in the world. That's my bad. I should have prepared better. Okay, ask questions. Do the daily assessment.